Hi everyone, welcome to Lecture 9 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. Today we will cover SPDF configuration of atoms. Before we learn how to write the SPDF configuration of atoms, we will first of all know what SPDF subshells are all about. SPDF subshells show the orientations and shapes of orbitals. SPDF subshells show the orientations and shapes of orbitals. So S subshell can hold a maximum of 2 electrons. P subshell can hold a maximum of 6 electrons. D subshell can hold a maximum of 10 electrons, and F subshell can hold a maximum of 14 electrons. So we now look at shapes and orientations of SPDF subshells. So this is the shape of 2s orbital, and this is the shape of 1s orbital. Remember the SPDF subshells, they show the orientations and shapes of orbitals. So this is the shape of 2s and it is the shape of 1s orbital. And this is the shape of p orbitals. So we have 2ps, we have 2py, we have 2pz. So this is the shape of 2ps, this is 2py, and this is 2p Z. And for the d orbitals, we have 5d orbitals. So this is the first one, dsy, that's the shape, ds and y. And the second one is dsz, ds and z. The third one is dyz. The fourth one is ds squared y squared. And the fifth one is dz squared. Okay, so we now look at assignment of electrons in an orbital. So let's say you have 3p raised to power x. This 3 represents the principal energy level. It can also be 2 and it can also be 4 or 5. This p represents the type of orbital, and the type of orbital, it can be s, it can be p, it can be d, it can be f. And this x represents the number of electrons in subshells. So for instance, for p orbital, it can hold a maximum of 6 electrons. So the number here, whether it is 2, 3, 4, or 5, it represents the principal energy level. This letter represents the type of orbital. It could be S, P, D, or F. And this superscript represent the number of electrons in subshells. Let's look at the electronic configuration chart. Remember that Niels Bohr proposed that electrons revolve around the nucleus in shells. So for n equal to 1, which is the K shell, it has s orbital. For n equal to 2, which is the L shell, it has s and p orbitals. For n equal to 3, which is the M shell, it has sp and d orbitals. For n equal to 4, which is the N shell, it has sp, d, and f orbitals. So the s block has 1 orbital and it can hold 2 electrons. The p block has 3 orbitals, 1, 2, 3, and it can hold a total of 6 electrons, 2 electrons for each box. The d block has 5 orbitals. If you count these squares, they are 5. So a total of 10 electrons, 2 for each box. F block has 7 orbitals. Each can hold 2 electrons, and it has a total of 14 electrons. Let's look at energy levels and sub-levels. For main energy level 1, the sub-level is X. Maximum number of electron pairs in sub-level is 1. Maximum number of electrons in sub-level is 2. And maximum number of electrons in main level is also 2. For main energy level 3, it has S, P, and D. So the maximum number of electron pairs in sub-level for S is 1, for P is 3, and for D is 5. The maximum number of electrons in sub-level for S is 2, for P is 6, and for D is 10. And the maximum number of electrons in main level is 18, and so on for the main energy level 4. Right, let's learn how to write SPDF electronic configuration for different elements. So if you're asked to write the SPDF electronic configuration of any element, you simply follow the direction of these red arrows. So we start from 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. So simply following the directions of these red arrows. So now let's look at some examples. If you are asked to write the electronic configuration for hydrogen, hydrogen has atomic number 1, so it has 1 proton and 1 electron because number of protons must be equal to number of electrons. So the electronic configuration is 1s1. So it is just 1 here because hydrogen has just 1 electron. For carbon, carbon has atomic number 6. So it has 6 protons and 6 electrons. And the electronic configuration is 1s2, 2s2, 2p2. So we have simply followed the direction of these arrows. 1s, that's 1s, 2s, that's 2s, and then 2p, that's 2p. So we stopped at 2p2 because carbon has just 6 electrons. And if you add up all the superscripts, 2 plus 2 plus 2 is equal to 6. Let's look at another example. Calcium has atomic number 20, so it has 20 protons and 20 electrons. And so the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So we have simply followed the directions of these arrows until we have completed 20 electrons for calcium. So for you to write the SPDF electronic configuration of any element, you simply need to follow these arrows, and you need to know that S contains maximum of 2 electrons, P contains maximum of 6 electrons, and D contains maximum of 10 electrons. So this is where I'm gonna end today's video. Please like this video and subscribe, and I'm gonna see you in the next lecture.